Hello everyone, we're going to talk about telescoping series now, and you can see right here we have a series that we're trying to figure out whether it diverges or converges. And one of the things that usually is a good indicator that a telescoping series is what we want to do is that we have a function being subtracted from another function. And so it doesn't always look like this initially. In the second video I'll show you guys how to look at it. But if I give you something where it's already factored like this, that's supposed to be a 5. If you see something like this series, then yes, we can still go and transform this into a telescoping series by using partial decomposition. So we'll do an example of that in our second video, but for right now we're just going to do this example that's right here. So telescoping series are actually pretty easy to see if it converges or diverges. The first thing that I always tell students to do is you just want to start listing out your terms. Just kind of see what happens as we start plugging in n equals 1, equals 2, equals 3, and n equals 4, n equals 5, etc. I just did that very quickly. I'm so sorry. So I get n is equal to 1. And so I'm just going to list out right now what's going to happen here. So if when n equals 1, that my first term here is going to be 1, and then I'm going to subtract, and then 1 over 1 plus 2 is 1/3. So this first term is going to be 1 minus 1/3. I strongly suggest that you do not simplify. You do not want to simplify at all this, and you'll see why here in a minute. And so now I'm going to go ahead and add my second term. Well, n equals 2 is going to be the next thing that I do here. And I'm just going to go ahead and do, okay, well, this is going to be 1/2, 1 over 2. And this is going to be minus, well, I'm going to put in a 2 here, I'm going to get minus 1/4. And so right now I've got the first term being 1 minus 1/3. The second term is actually 1/2 minus 1/4. And so now let's look at actually our third term. And so for the third term, with our little color coded and stuff here. So n equals 3. Well, I'm going to go ahead and do 1/3. And I'm going to do minus, in this case here, it's going to be 1 over 5, 1/5. And then I'm going to keep going with this. I'm going to go ahead and do 2 more sets for this. And so then n equals 4. Let's go ahead and just keep it gray here. So n equals 4. I'm going to get 1/4 minus 1/6. And then finally, our last one is n equals 5. And that's going to be 1/5 minus 1 over 7, and then dot, dot, dot. So what you guys can see here in these first terms is that this first negative 1/3 here, well, if we're going to keep adding all these terms together, then I'm eventually going to be adding 1/3. So this negative 1/3 here and this 1/3 here is actually going to cancel. And so then if you start looking at this negative 1/4, well, we have a positive 1/4 right here. So that's also going to cancel. And in the last time I showed you guys this, we have now 1/5 positive. We have a negative 1/5 here that's going to cancel. If we were to do a sixth term, you guys would see when n is equal to 6, I would actually put in a positive 1/6 term. And so that's going to cancel out with this right here. And so eventually I will have a positive 1/7 in my next term. And so everything is going to cancel out except for the only 2 terms that were left. So we have a 1 and we have a 1/2. So these are the only 2 terms that actually did not cancel. So the sum of this series is going to be 1 plus 1/2, which is 3/2. And we can now say that this series will also converge. So that's a really good way of showing you guys how to do a telescoping series. And this is the really easy way of actually finding the sum. It's just to list terms out as you go. So I will go do another example here in a second. I hope that made sense, and I'll see you guys again soon.